Problem number 4 has a word problem. We start out with a word problem. So Finland had the best scores on the living systems portion of the test. The scores of students from Finland were approximately normal with a mean of 625 and a standard deviation of 76. Now, part A says to draw a sketch that represents the distribution of Finnish student scores on the living systems portion of the PISA test, and be sure to include a scale on the axis. Okay, so if we're going to draw a sketch, I think I'm going to start with the scale first. I know that I want my middle. Well, I need to make it so that here, if I'm going to put my middle right here, then 1, 2, 3, remember, it's a bell shape. We know that it was approximately normal, so it's going to be a bell shape, and that almost all of it falls within 3, so it better be pretty finished by the time you get down 1, 2, 3. And symmetric. So see how I've got this bell shape, it's symmetric around this center, and 1, 2, 3 standard deviations. So now with my scale, I'm going to label this 625 because that's the mean of that test score with a standard deviation of 76. So I'm just going to use my calculator to go ahead and do that for me. Easier that way. So 625 plus 76, 701. Do it again, 777. Do it again, 853. And now go back down the other way, 625 minus 76, 549, 473, 397. Okay, so I've finished A. So that should be a pretty easy one for everybody. Just the thing to make sure is make sure your curve is really matching with what you're labeling. So it should begin and end somewhere around that 3rd standard deviation. Now B, approximately what percentage of Finnish students scored between 397 and 701? So if you look, 397 and 701 are actually here as part of the data, right? So if we want to use the empirical rule, because these are exactly on standard deviations, we can use that empirical rule, that rule that we actually wrote out on problem number 2. We know that 68% fall between here to here, right? We know that 99.7% fall from here to here, okay? So this is like one of those puzzle pieces, really. We don't quite know what happens from here to here, but what's nice is that we can say we know if we split it in half, that makes things fairly easy. I can pretty easily find out what this shade is right here, because I know from here all the way over to here is 99.7. We said that on problem number 2. So from here all the way over to here is 99.7. So if I take half of that, then I know 49.85 is on this half. Now I want to do the same thing right there. This is from here to here would be 68%, right? Within 1 standard deviation. So from here to here is only half of that. So 68 divided by 2, 34 right here, right? So adding the 2 together then, 83.85. 83.85%. How do you know? So if you show this kind of work, you could say, see the work I have, or you could write out, I know from 397 to 853 is 99.7, so I took half of that. I know from 549 to 701 is 68, so I took half of that, and then I added together. All right, C, approximately what percentage of the students scored higher than 550? So 550, is like not quite on here, right? We could come up with an approximate, right, if we wanted to use the empirical rule. But if we want a little bit better of an estimate, we should probably use our z-score chart. So since it doesn't fall exactly on one of the standard deviations. So z-score chart, first step, you need to change the raw score, that 550. And we want higher than 550, right? We want all the way higher than 550. So we need to change 550 to, that's a raw score. We need to change it to how many standard deviations? We know it's almost 1, but it's not quite. It's going to be like maybe 0.9 or something. So you find out how far is it away. So it is 550 minus 625. That equals negative 35 away. And then you divide that by the standard deviation, which is 76, right? Oh, it's not negative 35. Good thing I checked myself. That did not make sense, right? So 550 minus 625, negative 75. And then divide by the standard deviation, negative 0.99. Okay, so remember this is a z-score to the nearest hundredth. So negative 0.99, and it's negative because this is below. The 550 is below. So now we want to use the z-score chart. I forgot to bring my z-score chart home, but it doesn't actually matter because if you go to my website, so spartanmath3.weebly.com, right? Go there, and then if you go to the homework, and you go down to that homework page, there's a link to get a z-score chart. Okay, so I'm going to pull up that link, and I have a z-score chart now, and I have to find negative 0.99. So let's see if I can get this close enough that you can see it. It's a little bright, I think, for it to focus on, but I'm looking for negative point. So on this side, I need to find the negative 0.9, which is like right here. And then I need to go over to the 0.9, but you notice that's the first column. So negative 0.9 row, and then the 0.09 column, that's 1611. So if you have your chart, you'll be able to see that more clearly. 1611, let's see. 1611 right there. Okay, so 0.1611. So basically, we've got a 16%, right? But the thing is that if you look back now at our, this wouldn't be 16%. We want above 550. So you have to remember the 16% is below that line. 16% is below. So this is 16%. What's on the other side? That's 100 minus 16%. So 100 minus 16% is 84%. So 84% is on that side, which pretty much you would have gotten from the empirical rule as well because it's so close. But I wanted to make sure you remembered how to do a z-score problem. So remember, you change the raw score to a z-score by subtracting and dividing, right? And then you use the z-score chart to change it to a percentage, which gives you shading below. If you need shading above, you subtract. All right, the last question on this problem is D, what test score is at the 90th percentile? So this is moving backwards now with our z-score charts. We want to know the 90th percentile. That means that we want to find the raw score, that if I shaded it, 90% would be below the line. So if you're looking up here, 90% below the line. Okay, so we need to figure out somewhere in here there's going to be a line with 90% below it, but we need to know where that is. So we're going to use z-score chart backwards. So go back to my z-score chart. And I need to find 90th percentile, and that's definitely not going to be on the negative side. That's going to be up here on the positive side. So I'm looking in here. So remember, 90% is the same thing as 0.9000. So I'm looking for something close to 0.9000. Here I've got 0.9032, 0.9015. Okay, so it looks like, and then, oh, this one right here is really close to 0.9000. It's just like 3/10,000ths away.
So this one is the closest. So now I just need to convert that to a z-score. What's the z-score for that percentage? 1.28. Okay, so 1.28 is my z-score. But I don't want to know the z-score. That's how many standard deviations away it is. That means one standard deviation away from the mean plus a little more. Somewhere in here is the 90th percentile. But I don't want to know how many standard deviations away it is. I want to know the actual score that the students got on that test that would have put them in the 90th percentile. So I need to convert this back into raw score. So you take that, and I know that 76, one standard deviation is 76 away. So if I take 76 times 1.28, that'll give me how far away from the mean it is. And then I add that to the mean, that'll give me the raw score. So taking 1.28 times 76 plus 625. So that would be 722. And you can either write 0.28 or you can just leave it set round to 722. So the raw score is 722. If we shaded there, 90% got below that.